Okay, I'm going to show you some things about relations. This should be a pretty straightforward section. So, alright, let's go ahead and roll. Looks like my little tool thing is not working great, so we'll see what we can do. Alright, first thing, what is a relation? So, a relation is a set of ordered pairs. So it could be a whole bunch of ordered pairs, or it could be just a couple. It doesn't really matter. So it's just a set of ordered pairs. It's x's and y's. Okay. So and then there's it's really important in this section that there's 4 ways that you can express a function, or not a function, a relation. So there's 4 ways to express a set of ordered pairs. 4 ways to express a relation, which is a set of ordered pairs. So here's one way, ordered pairs. So we might see it as 2, 2, and let's say -1, 3, and then 0, -1. And then I'm going to put probably the whole thing in brackets, and I'm expressing a particular relation. This is just one I made up, and it has 3 ordered pairs. Well, I could also show this exact same thing in the form of a table. So I can make a little XY table, and I could, the point 2, 2, I would just say 2, 2. And this point here that says -1, 3, then I would just have -1, 3. And then the next point would be 0, -1. It's the exact same thing, but it's in the form of a table. And then we have mapping. And mapping is a little bit different. Mapping is when you have like this oval, and then you've got another oval. And the first oval is supposed to be the x, and the second oval is the y. And you just put the numbers inside of there. So the x's, I would, for this particular one, I'd have 2, -1, 0. And then for the y's, I'd have 2, and then 3, and then -1. And a mapping means that you're actually showing the connection, when the x is mapped to the y. So in this case, the 2 would go to the 2, and that creates an ordered pair. That would be 2, 2. And then -1, 3, it shows, you have to do the arrows too. It's important, the direction of the arrows. So -1 goes to 3, and then 0 goes to -1. And again, arrow is that direction, so we're going left to right. And then the 4th way to show that exact same relation is a graph. So if you had a graph and you wanted to show somebody that one of your points was 2, 2, then you would just go over 2, just like we did last section. You would go over 2, and then you would go up 2, and you put a dot, and it would show that particular point. And then if you wanted to show -1, 3, then you go over -1, go up 3, there's that point, there's that ordered pair, and then 0, -1 would be that particular point. All 4 of those say the exact same thing. Okay, here's an example. It says, write the relation as a set of ordered pairs and state the domain and the range. So we're looking at a table of values, and the first thing is, if you want to state it as ordered pairs, then you just use the brackets. A little prettier than that. Do a little prettier than that. So you do these little bracket things. And then you just write the ordered pairs that you see there. So -1, comma, and the y that goes with it is a 3. And then we got, looks like 0, 6. And then we got 4, -1. And then we got 7, 2, and then we got 15, 16. And that is the set of ordered pairs. That's the exact same thing. And now if they say, hey, can you figure out the domain? The domain are just the x's, if you're using x's and y's. And the range are the y's. The domain is the first element. So the domain, we would maybe say it like this. We could say the domain would be just the x coordinates. So the domain would be another set of brackets, and you just pull out the first coordinate. So that would be -1, let's see, 0, and then 4, and then 7, and then 15. So that's the domain. And then the range are just the y-coordinates. So the range would be 3 and 6 and negative 1 and 2 and 16. So that's the range. Okay, so there's that one. Next example, it says write as a set of ordered pairs and write the inverse. Alright, so first I have to kind of finish what this problem is. It's a mapping, and it's not quite done, so I have to show what the relationships actually are here. So I've got, let's see, I've got negative 1, it's going to the negative 6. I've got 3 going to negative 4. I've got 3 going to 2. I'm going to say that the 4 goes to the negative 6. So if you wanted to state what the ordered pairs are that are represented by this mapping, you just start with negative 1. So you'd say, okay, I've got negative 1, comma, negative 6. I've got, let's see, 3 goes to the negative 4. So that would be this whole thing. So I got 3 going to, sorry for that messed up looking thing. Alright. So I got 3 going to negative 4. And then I have 3 going to 2. And then I've got 4 going to negative 6. Alright. Now, the thing I'm just throwing in there is called the inverse. And the inverse is just when you switch your x's and your y's. So inverse just switches the x's and the y's. It's really simple. So switch x and y. And so the inverse of this same function is the exact same thing, just switching the x's and the y's. So instead of negative 1, negative 6, then it would be a negative 6, negative 1. Instead of 3, negative 4, then it's it's negative 4. It's negative 4, comma 3. And then it's 2, comma 3. And then it's negative 6. You're detecting a low battery mix with the memory. Okay. And so negative 6, comma, sorry for that. Negative 6, comma 4 is what that's supposed to be. It's a little tough to read now. That's a negative 6. Alright? So all you do is switch your x's and your y's. Last problem. Write as ordered pairs and tell the domain and the range. So again, same thing, except it gives it to us as a graph. So can we tell what the ordered pairs are as you look at this graph? Hopefully. So it looks like we go to the left, negative 2, and then down 1. So this point would be a negative 2, negative 1. And then this point looks like you go over 1 and up 1. So that point would be 1, comma 1. And then this point here would be over 2 and up 1, 2, 3. So that would be 2, comma 3. That is the set of ordered pairs right there. Now the domain again is just the x-coordinate, all the x-coordinates. So the domain is like this. So we'd say negative 2, comma 1, comma 2. That's the domain. And the range are all of the y-coordinates. So the domain is negative 1, comma 1, comma 3. And all you have is points. Okay? And alright, I think that should do it for this section. Let me make sure here. Yeah.